keyword. So this is if you're in the standard vocabulary and you've chosen to say that there's a myelinite in this area, you can see, okay, they're mostly in the Western United States, at least as located now. What you'll notice, though, is that you can do other things at the same time. For instance, you can say there's a strat column. Where do we have strat columns? This is from 3 weeks ago, so there's many more now. And it shows you where they are. But then you'll notice that there's this plus button. And so this works very much like a GeoRef type search, where if you click the plus button, you can say, well, I want a strat column, but I also want to know where there's the keyword carbonate at the same time as a strat column. So you have the ability to do pluses and minuses. So to add things to the search or to take away things from that search. So I think that utility is going to be very helpful for us. And I've just blown that up on the right-hand side. The other thing you can do is keywords. And I wanted to point out that when I'm now showing a particular spot, again from Baraboo, where you have a whole bunch of tabs, if there's a place, the keyword searches are more difficult, but if you put them in this notes, so that's the second possible tab you can put up. This was done for teaching, so it has a bunch of things in it, but this is the place where we're going to do the first sort of versions of keyword searches. So if you need a keyword to come up, they just need to be in this general notes page, at least for the time being. And that's basically it. It's a work in progress, and it should solve many of our problems moving forward. And I think that's all I have to say about that.
All right, thank you, Basil. Does anybody have any quick questions on search functionality? One thing I'll add to that is, along with the search functionality is some download functionality into different formats. That's being worked on as well and will be more advanced. Right now, it's fairly rudimentary on getting data out. And Jason, you're on board here. What are all the formats that we can get data out into right now?
Let me take a look at the website here.
Okay. Anyway, while we're waiting on that, we'll have the next presentation is going to be by Casey Duncan, who's a graduating PhD student at University of Utah, and he's going to be working, and he's worked on and is going to tell us about the Strabo sedimentology and Strat mode.
Doug, the options for download are shapefile, KMZ, Excel, StereoNet, Fieldbook, and Strat column.
Okay. So those are we'll be building on that in the future. All right, Casey, take it over.
All right, well, thanks, Doug, and hello, everyone. I've seen a lot of familiar names in the participant list here, so hopefully this isn't too much of a rehash of what we did a couple weeks ago in the SED workshop. But what I'm going to do today is just give you a very brief walkthrough of some of the sedimentological and stratigraphic options we have in Strabo Spot. The foundation for all of these boils down to this vocabulary list that was developed and refined over several years. And that forms the basis for these SED tabs. Now, you've probably been using the images tab and the samples tab and those other options, but the SED tabs allow you to add SED specific data for 6 main categories listed here. Some of the tabs have sub tabs, so it gets a little complicated very quickly, but this serves as a good way to organize the data inputs. Strat mode itself uses those tabs in the vocabulary to be able to build a stratigraphic section within Strabo. And we refer to this as Strat mode. This is a new map mode that is essentially a one-dimensional map where it tracks the stratigraphic coordinates of input spots. You can do still point line and polygon spots, but the new or this map mode relies on this new kind of spot that we call the interval spot. And another thing I'll just highlight here is that we've not only with those tabs, but we have what we call the add interval dialog, which interfaces and kind of bridges the gap between the map mode and those tabs. So you can very quickly build up the stratigraphic section in Strabo. And if you remember anything from today, the main point of this is within the overall geologic information system that Strabo is. With Strat mode, we can now track and document stratigraphic as well as geographic relationships. All right, so with that, we're going to switch over to Strabo Spot website. Now I'm going to be demonstrating using the version accessible through the website because I don't have a way to link up my iPad to my computer. But to get there, I'm logged into my Strabo Spot account, go to My Data, and this will bring up all the projects that I have. And we're going to be working in this just demo project. And so if you select the View, Edit, Add Data, it'll bring up Strabo. And the view here is slightly different from what you see in the mobile app, but it's largely the same. The main difference is your menu options are available at all times across the top here. So we're going to be working in this Green River Channels data set. So I've already added that, but I'm just going to activate it. And one other thing that we'll need to do here is we go into Project and go to Preferences. We're going to make sure we've got the proper tabs activated that we need, and I only need images, but I'm also keen on having all of my set options, and you can pare this down. If you're only going to be describing basic lithologies, then you could just keep the single tab open and have the rest deactivated. But the key thing for this is we're going to activate this Strat mode with the toggle. One thing to point out and to note, with Strat mode activated, when you go into Maps, Strat sections then becomes an option for view. So you can view all of your stratigraphic sections that you have available or that you've added. But we're going to go into this main map here. And for today, we're going to be focusing in, zoom out here to give you the proper context. We're here in South Central Utah, near Green River on the eastern flank of the San Rafael Swell. And we're more or less focused on the Cretaceous stratigraphy that's exposed here. I'm going to go ahead and hide that and switch over to the satellite view. And what we're going to be doing is describing a really quick section, very basic section through a portion of these weird curvilinear sinuous ridges of the Cretaceous Cedar Mountain Formation. This is a classic example of inverse topography where the channel forms and the sandstones and conglomerates that make up the channel are now exposed in positive relief or as positive highs, whereas the surrounding floodplain material has subsequently been eroded away. So we're working on a portion of this particular channel, and there are a few different ways that you can sort of document the georeferencing for your stratigraphic section. If you're working in thin exposures of horizontal strata, then and you're able to essentially move vertically, that georeferencing in this map view could be accomplished with just a point spot of a set radius. Alternatively, if you're dealing with dipping strata, say we're starting our section here in the lower part of this floodplain and start climbing the hill, what we might do to document that pathway is we could set a line spot to show that path. But since we're only doing a short section through this, very shallowly dipping channel form, a point spot will be just fine. So we'll go ahead and select that. And once you do, it pops up the spot page. I'm going to rename it real quick to KCM-1. Save my changes. If you're working in the desktop version, you need to hit save frequently. Now we could add other notes. We could add some estimate of the GPS accuracy and rock unit tags. But for today, I'm just going to say that this is, the radius for this spot is about, we'll say 10 meters. That'll capture any, we do have to make a short horizontal offset to make it through this, the cliff face, but a 10 meter radius would be just fine. So we'll collect save. And to show you what these channels look like from the ground, if I go to the Images tab and add an image from file, it is a photo. If we navigate to the folder that contains the file, give it a couple seconds. And I'm going to give this a quick name, just KCM outcrop will do. Save our changes. And then go into the folder, or the photo. This is what we're dealing with. This is what these channel forms look like from the ground. Now here's Basil and my advisor Margie Chan standing at the base, looking at the floodplain, fine grained material, claystone and siltstones, caliche layers, and this is scoured down into by these big channel forms, this package of cross-bedded sandstones that form the bulk of this exposure. So this is what we're going to measure a quick section through. Okay, so since we added all of those said tabs earlier, you see we've got quite a few options. All of those tabs then become active and available. And at the spot level of KCM1, we could start adding lithologic information, as well as images and samples and the like. And so we could associate sedimentological data just with this kind of master spot that controls all of the subsequent spots. But we want to track the stratigraphic relationships within this spot. So we'll go to this Strat section tab, toggle the Add Strat section, and this brings up a whole host of options for recording really critical metadata for the section. So we can give the section a name, and I'm going to go ahead and name it that. You can change the column profile based on whether or not you're working in a clastic or a carbonate system or a mix of the two, or you can plot based on other attributes, not necessarily composition. But we'll keep it at clastic. And I'm going to toggle on the display lithology patterns. I'll keep my units in meters, but you can change this to centimeters if you're doing sort of a high resolution study, or if you're working with core, you can keep it in the appropriate units for that. I'm going to go ahead and designate this as a single outcrop, but note that you can do core and well log as well as composite. And there's other data that we could associate, but I'll leave that to your exploration of the options. So we'll go ahead and select Save Changes. And then before we move into actually building the column, I'm just going to go into, I'm going to add an image overlay from the get-go. Now I've already played around with this photo, so I know what settings to use. So if we add that image that we just added to this, the KCM-1 spot, and then we can designate the coordinates for where the lower left corner of that photo will occur in pixel coordinates. The image width, again in pixels, and then we'll set an opacity. Now you can play around with layering if you have multiple overlays. You can set that there with the Z index. So we'll select Save, and now let's go into the column. Now we can do this in two ways. We can go just by selecting this View Stratigraphic Section, or again, you can go through the maps and go to strat sections. We're going to click here. And it brings up our strat section here, and with the image added in the background. So this is what we're going to describe real quick, rapid fire, just to give you a preview of the functionality of adding data, defining intervals, and the like. And we'll start here with this base, this somewhat recessed interval. I'll point out that you have your standard map tools available, your zoom controller, your spot palette, layer manager. If you have multiple image overlays, you can toggle those on and off, either individually or collectively. But our options here change slightly as up in our tools that are available. One is we can view the interval spots that are available or that you've added and view them in stratigraphic order. Or we can access some other options, and to return to that previous screen, we would select this strat section settings. But we're going to go ahead and add an interval. So that's this little plus icon. Select that, and it'll pop up. There we go. Now you'll notice there's a couple things that are underlined in red. Those are our required inputs to define the stratigraphic thickness and the grain size of the interval. That's kind of our minimum information needed to build up this column. So our first interval, we'll call it A. This interval is 0.6 meters. And here's a kind of an important component for this is we can start defining the attributes of this spot in terms of its sedimentary characteristics. And here, we can designate it based on some other criteria, but we're just going to keep it simple and say it's a bed of siltstone. So we'll go to siliciclastic type, select siltstone, and it's ready to go. We press save, and it plots a little box 0.6 meters high out to the siltstone. So let's continue on, and let's plot this interval here. It's slightly more resistant, and we're going to do this in a time-saving way. So we could add the information for each bed as we go along, but there's a function here, copy interval data, that allows us to just copy the sort of primary characteristics of the bed, but it does not autofill the interval name or the thickness. So we just have to go in and define those. Hit save, and we're all set. Okay, let's do two more intervals. The next is this claystone interval. So unfortunately, I can't copy that over because it's different grain size. This one is 0.4 meters, also a bed. This is a mudstone, all ready to go. And then let's add a spot to characterize this. We'll just take the lumper approach because I'm talking too much, and we'll add that. This is 3.5 meters, but a bed doesn't really capture the essence of this interval. This is a package of beds, trough cross stratified sandstones with minor conglomerate mixed in. So we'll call this a package. We'll define the overall type as a sandstone, and its main grain size is a medium upper. But one thing you'll notice is, since I selected package of beds, a new option has popped up here to characterize the average bedding thickness for these beds. The interbedded and bed mixed lithologies also have their own pop-ups. So our average thickness of individual beds is 30 centimeters. And so we've been able to very quickly build up a column. And if you wanted to add more information to each of these spots, then we can go in and add images that are tied to these intervals. We could add a lot more lithologic information for each. And then finally, what I'll show you is now that, is how we can track other data types in here. So say we found something cool at say the 4.5 meter level. We can add a point spot there to document that, save it with some cool concretions, save our changes. We can add some photos to this as well. We'll go back into the measured section and it's logged that. All right, that was a quick, very quick rapid fire introduction to Strat sections, and I'll call it there.
Well, that was great. Casey, would you take a question or two if people have them?
Certainly.
Any questions for Casey on Strat mode?
Do you have any recommendations for naming each of the intervals?
That's, I guess, more what you're used to in your own workflow. There is a way that you can set that up to auto name, so you don't have to keep renaming things as you go along. But yeah, I'd say what you usually do, or.
What do those strat columns look like in the main map view?
So it depends on, well, in the main map view, they don't display at all, but they are tied to sort of those higher hierarchical level point, line, and polygon spots on the map. Another way that you can geo-reference a strat column is by adding a base image, and then you can draw, a line or point, line, or polygon spot on the base image. But through the main map view, the strat columns don't display.
Okay. So I think we're going to go into Joe Andrew here in just a minute. But Basil and Randy, I think both of you had something you wanted to offer up on the projects.
So this is Basil. The only thing I did is, given the number of people doing projects, we can boost the amount of money per project to $250. If that entices you, that's fine to participate. And again, my apologies, but we can only do that to people at U.S. institutions. So that's all I have to say.
Randy.
Yeah, we've been getting a lot of questions in the last couple of days about what sort of counts, as want of a better word, for a project for this particular exercise. As Basil sort of indicated on day one, we don't have any fixed rules about what exactly your project can or can't be or needs to be. The only thing I would offer is that the idea is that the projects need to be something that is both original and relatively cohesive, meaning that, taking somebody's geologic map from the 1980s, for example, and digitizing it and putting it into your account in Strabo is great, but it's not really quite what we're looking for. Similarly, sort of random collections of strikes and dips of beds, like from various places in the world, would not quite be what we're looking for. We're looking for something that's sort of more an actual cohesive part of a research project. It doesn't have to be the complete project, but it does need to be something that's original and cohesive. The other thing we've been getting a question about is size. We don't really have any specifications on what the size of your project needs to be, but we do understand that you have about 3 or 4 days to produce this in terms of somebody seeing it. So we're not expecting them to be huge. That's all I have.
All right. I think I'll turn it over now to Joe Andrew. Joe, are you out there?
I am ready.
Go for it.
Let me see how to do this. No, I don't want that. How do I share the whole screen?
I'm seeing your whole
Oh,
screen.
here. No, it's just one window, I think. I think this is it.
Okay.
All right, so I was just going to give an example. I've played around a lot with the desktop version. This is my projects on the website, and these are all data sets I've been playing with or uploaded. So I have a lot of the search that Basil was talking about pulls up my data, for better or worse. So today I'll be talking about the Airport Lake Fault. So this is the earthquakes we had July 4th and 5th last year in Ridgecrest, California, just an example of using the desktop version for all of that. I'm not going to do the whole process of loading because the project I'm working on has, at least one of the data sets has 7,000 features, which takes 2 or 3 minutes to load. So we'll just skip right to the map. So here we are, here's California. And we'll be working sort of in this area of active slip. And there's some weird things here like the Garlock Fault. I won't get into all the detail except to say where we are. So zooming in here, this is a smaller data set that Doug Walker collected in last year, actual field work. So I'm going to be incorporating a whole set of data sets. And that's really where the desktop comes in, is you can have all the things on your little tablet, but with a bigger screen and with more access to sort of bandwidth, if you will, you can do a lot more. So for this project, I have all sorts of things. I have, if we go back to the Strabo Spot website, you can also upload geotiffs. Geotiffs of anything, as long as they're referenced to the world somewhere. So I have a lot of those also, and hopefully those will be searchable at some point. Everything from geologic maps to some shaded relief made from LiDAR. So that's infinitely flexible, and if you use, there's different mechanisms to do that with it, but within Strabo Spot, it's quite easy. It's just add new map. If it's a geotiff, you just upload it. Sometimes there's an error, you can fix it. And then what you'll need is this code. So when you're actually in the Strabo Spot sort of map view, the desktop version of the map view and database, you'll need this code to pull these up. And you can also make these public or not public. You can view them. So for instance, this one here, we can just view that, and it pulls it up and it shows you where it is on the world. You can zoom way into it if you want to, pixel scale or greater. So all of that is really flexible and really easy to use at this point. So if we go into the map view, we have the same sort of layers as background. I like the satellite view for these kind of areas. And then I can pull in my actual data set that I'll be working with today, which is quite extensive. And it kind of it's getting on the upper end of slowing down the system, especially if I have other layers of actual GIS data that are all sort of in the Strabo database. But what I'm doing today is the earthquake last year partially occurred on an area where there was no previous known faults that were young. And what we're doing here is we're looking at that area. It goes through an area of Jurassic bedrock and then also younger units as young as Pleistocene sort of lake sediments. And going through that and looking not only to find the actual fault scarps, but trying to find total offset, or even better, if we had different ages of things, to get sort of increments of the slip history. And this is all in the horizontal view. This is a left lateral and also a right lateral fault that all kind of moved together here. And then the Garlock is a major feature cutting through here, and that sort of is in the project, but not quite in the project. So this area here is called the Spangler Hills. And then if I were to zoom in, my computer is not very happy with all of this. But as you can start to see, there's numerous dikes here. And as you zoom in more, you see more and more dikes. There's more than thousands of dikes here. And when you're on the ground, they're actually kind of hard to see. Sometimes in the more sort of uplifted areas, they're quite easy to see, but there's also areas of extensive gruss where all you see is maybe part of a dike popping out. And it's quite a difficult area to map on the ground. And so this is a really good sort of first step to identifying things, characterizing things, getting some candidates to look at, and then we can go out and test everything with field work in a sort of more efficient way. So this is all Jurassic bedrock with some younger units around it. And the importance of this is, well, to look at this earthquake, to figure out how these faults move. This is an area that really didn't have many faults, even though geodetic data was telling us this is a prime candidate, and it was. Pulling up the actual thing. So this is your map view project. I have all of my layers. I previously loaded this other layer, which is down here. So it won't take 2 minutes to load. So there's only 7,000 spots there. And I pull that up. So it's quite a number of spots. And one area is really key, and you can see this is really slowing my computer down. There's sort of a, and you can, the nice thing about Strabo is you can just turn all these layers off and it doesn't matter. So in this area, it's not, we're getting sort of out of the bedrock, and this is more of the quaternary features. I have quaternary maps of that, of this G.I. Smith went here and mapped everything, and I could pull that up if I wanted to. I could pull up the USGS map where they tried to map the fault scarps. This is just straight from a PDF. I just ripped this out of a PDF from the US Geological Survey. I threw it on a map, georeferenced it in GIS, and then just uploaded it to Strabo. So 5 minutes later, I had this layer in my project. I also did some other things, including taking some LiDAR data, making shaded relief in ArcGIS. And this actually came out really beautifully. You can see all of the Pleistocene lake shorelines and lake sediments and tufa mounds. And then there's also these pretty conspicuous faults cutting those. These faults are basically the along strike versions of some of the USGS scarps. And when I looked in depth, I can find offsets of, I guess these are layered oddly. I can find offsets of the dikes. And so I can try to put that together of how much offset of dikes, how much offset of the Pleistocene, and there's also some Pliocene units involved also. So it's pretty powerful in that way. And I can also search through and plot different features. So when you might have seen this when you have your Strabo project, you have all the spots and you can see like, I just want to hide all the bedding. I don't want to look at that right now. And you can hide other features. I just want to show all the faults. There's all the faults I've mapped. Maybe you can tell I've spent a long time using this desktop version for this one particular project. So here's a sampling of those. I could put on dikes and depositional contexts, also a huge number of those. Doug Walker also had a master's student that worked in a nearby area, is at the other end of these mountains. And it wasn't really a finished master's thesis, but we had GIS data from them. And I also had a folder full of photos, a digital folder full of photos. And so I went back and I changed his GIS database into Strabo, and then I added the photos because I could get the links from his notes. And so I built sort of a database, a Strabo database based on that to combine with everything. So I have all of these things going together. And it turns out there's another fault system at this end of the range, and then there's the sort of active one that just went off here. They're both relatively active in the long-term sense. So I have all of these things mapped, and it gets kind of messy because Strabo likes to put all these labels on here. Maybe that would be a thing that if we could turn those on and off as sort of a dream feature. Thinking small here, but that might be nice. So I've mapped a lot of the dikes. I've tried to find out where they were and then classify them just like you would do out in the field if you were mapping something, trying to find unique features in those. There's a set. Actually, unfortunately, a lot of the dikes are parallel to the faults, so that's not so good. But there's also a set of relatively unique felsic dikes that go sort of to a more northeast strike. And I've tried to put those together and find sort of matching matching dikes to have as candidates for when I do field work. And I put that together and I kind of tweaked the Strabo vocabulary for that. And I made these things, I called them fence lines, anthropogenic features. They're not fence lines, but it's just a way for me to denote something different and to be able to call them up instantly. And this is all of the places that I was able to find things that I could match up. So I can, since I used a different terminology, I can easily pull those up. And I have been able to identify quite a number of these to go out and test with fieldwork. And it turns out that the Jurassic ones that match the ones in Pliocene rocks. So that was an interesting thing that I can go out and test now with fieldwork. This part of the system only seems to have a kilometer or two based on this analysis. And then the Western system has a much larger horizontal displacement of about 7.5 kilometers or 9 kilometers. There's actually 2 faults there. I can also pull up, I don't know if anyone's used the images tab very much, but you can pull up all the photos that you have. Again, these take quite a while to load. When I have all of these layers in, the system is quite bogged down, especially in the middle of the day. It seems to be a little bit better in evenings or sort of off time. So here's a few of the photos. These are some of the ones that Doug Walker took out in the field of the actual earthquake sort of remnants, like a fence that's dislodged. So you could search through your map just looking at some of the photos if you wanted to, or your different databases. And it kind of pulls them all together. If you have the layer active, you can use it at this point. And the more features you have, definitely it slows it down. I have a couple of the GIS databases that I pulled in from other projects that have 20,000 features, and at that point it's quite frustrating. And maybe that's just a cache problem on my computer or something, I don't know. For this, the sort of satellite imagery that is available in Strabo itself is more than adequate, and sort of the biggest problem is sometimes when you're looking at this scale, and if you go to the next level, it might change the photo and change sort of the colors or the contrast of those different features. But there's actually quite a bit you can map at this level of everything from, these are just sort of Pleistocene deposits, the Jurassic deposits, dikes in the Jurassic. And again, sort of going through that one by one, many of the dikes are more mafic. There are felsic dikes. This would be a felsic dike here. And each one of these has information of quality. So this is zoomed in too much. You can start to see it's blurry. So the felsic dikes are sort of here. You can see they're a little bit more pink in most of these satellite photos. And I don't think I have can't really show everything here. There's shorelines in the Jurassic rocks. And this is sort of the main fault zone is sort of in here, or one of the main fault zones on the US Geologic sort of summary of brand new fault scarps created by the earthquake last year. And there's a system of dikes here that are well exposed that are relatively unique looking. If I can zoom in on this one, this is sort of one of the key ones. And then hiding, again, it's really easy to hide your data. So there's a felsic dike here, which is relatively well exposed, probably on the ground. It is locally well exposed, but overall, maybe not. I thought we had a picture of one of these. The actual field work. I don't see it at this point. But this is just sort of the first stage, and I can take all of this data and easily put it back, throw it back into ArcGIS if I want to, and then bring it back to this. There's a couple things that I'd like to refine on that, but as I go through, I can identify what needs to be changed to make it work a little bit better and more efficiently. But overall, I'm pretty happy going from GIS to this back and forth. And again, the GIS is really good for making anything georeferenced, throwing it in here. There's other ways to do it. There's web applications, there's the map toolbox, but the Strabo maps are really the way to go. It makes it really easy. You can share that code also. So if we go back to this, My Maps, this code is shareable. I'm not sure if it matters if it's public or not, but anyone can access these. If I shared you this code, you could look at my shaded relief or these other geologic maps that I've thrown in here. I don't think I have too much more there. And if anyone has some questions or other things that I've done with this, I'd like to present the rest when I actually have field work.
Can I ask a question?
Sure.
Hi, this is Lisa. You've mentioned going back and forth between ArcGIS. And so I'm curious, because I've done a lot of what you're doing, but just in ArcGIS. I'm wondering if you could comment on when are you using Strabo Spot desktop? Because it sounds like you're doing a lot of things when you're back in the office that I do in GIS. And so could you just talk a little bit about like how you're using the two and when you're going back and forth? And it looks like the advantage of doing this, a lot of the work in the desktop in Strabo Spot is then when you go out to the field, you have all that with you maybe more easily. But I'm just curious, I haven't used Strabo Spot much. So when would you use the two?
Like one of the biggest benefits of the Strabo Spot is once you have things accessible in Strabo Spot, it doesn't matter what computer you're on. It doesn't matter who wants to look at it. As long as they can get onto the website, they can see your data. Whereas with GIS, it gets a little bit more complicated. Yeah. And you have to think a little bit more about formatting and does somebody even have an ArcGIS license, et cetera. So that's one of the really great benefits. I did find I was going to ArcGIS sometimes. And for example, in this one, there's thousands of dikes on here. I didn't want to go through the Strabo workflow to categorize every one of those dikes. Most of these dikes, I would say, are approximate to known when you're just looking at these satellite images, at least in the well-exposed bedrock. And so I would basically go in and map a huge number of these. Then I would go to GIS and I would categorize them as a group. And then I could bring it back into Strabo because we don't have that sort of mass calculation ability right now in Strabo Spot, or if we ever will. But in GIS, that's relatively easy. The other thing I did in GIS was background imagery. The satellite imagery was actually better. I had a better access for GIS. And you can also, with GIS, you can increase the contrast and do a couple other things with imagery that we can't do anything with the imagery as easily on Strabo Spot. So that's sort of the main pros and cons, I guess.
And you're going back and forth. So you'll go into ArcGIS and, lump things, put them in a group, separate them out into layers, and then bring that back in. But you're kind of going back. I hear you saying you're going back and forth a lot. Yes, and it could be a little bit more streamlined, but I'm sort of identifying any of the roadblocks or sort of stumbling blocks to do that. Okay, great. Thank you.
Other questions? Again, I'll put in a plug here. There are some ARC and QGIS plugins that are written. The logic is all there. The heavy lifting is done. We just need to get them updated for newer versions. Those are at GitHub, and you can contact us if you want to jump in and work with those. The mass or larger number of classifications at a single time is being worked in, and we'll get an intro into that on Friday. And let's see, what else? Can't think if there's anything else I wanted to add to that or not. Basil, do you have anything you want to add?
I don't think so. I think we should take a 5-minute break though, and maybe reconvene at the top of the hour, just in case people need to go get a coffee or something. And we can just stay here and answer questions while people are doing that. And then we'll start the formal presentations then.
Okay, we'll start back up again at 2 o'clock.
I had a question for the last presenter. Kind of, I guess, building off of my chat question about how each individual line looks like it gets labeled when you're out mapping. And I noticed that I was kind of out in the field playing with things yesterday. So looking at your map, every single one of your lines has like a 4-digit number to it. And so you're creating those 4-digit numbers as you go along. Does it get kind of, especially the extensive mapping area that you're working on, doesn't that get kind of arduous and confusing with that massive amount of labeling? And how do you keep track of what different polygons are?
Well, polygons are a different thing. You use the tab or tags to do that. So for the polygons, you can define a tag and you can define a color and you can say, this is all the notes that are associated with this rock unit.
Okay. Oh, yeah. So I guess, sorry, just using the wrong vocabulary, but even still, you have, a closed line that you've made with your mapping, and presumably you're going to take that into ArcGIS or some other GIS or Illustrator or something to make a map. But it seems kind of confusing how you kind of keep track of what each of those units are.
Right, you can do that. I usually do that with sort of points and notes. So if I have point data within them, or I could even define just a new layer of just the rock points or something like that. And I would do it via tags and things. This one's a little bit easier in that sense, but I also created all of the geologic units, yes, in ArcGIS, just because I want to have edges. The edges defined easily. As far as the numbers, those numbers are assigned by the Strabo spot. It's basically just the intervals in your database. You can rename those if you want to, and they do get kind of cluttered. As when I was sort of zoomed out, it just looked like a pile of numbers. So it kind of, I think it would be nice to be able to toggle those on and off in the future. Did that answer that?
Yeah.
More questions? Does anybody have any questions about how to go about doing anything?
I put a question in the chat. I'm interested in importing shape files of, for example, strike and dip measurements, which have their own structure of attributes. And I'm just wondering, how do I match up the attributes in those shape files with the attributes that Strabo expects, that are like the tags or whatever is attached to the spots in Strabo when they come into Strabo?
Doug, are you on the line?
I'm on the line, or Joe, do you want to handle that?
Well, you could make a spot, export it, and look at the sort of the geometry. If you wanted to make a spot and this is fault measurement and all that, and then you could export that on the sort of the My Projects page. And then you could just open that up in some program and you can see all of the database fields. It's just sort of a spreadsheet.
Okay, and then I would convert my old file to match the format that
So, Joe, I think he's talking more about the shapefile import functionality.
Right.
So on shapefile import, it goes through and it looks at what attributes you've assigned, and then it lets you assign Strabo spot attributes to your attributes.
Oh, so there is a dialog that allows you to match the attributes one for one as they come into Strabo then?
Yes.
Okay.
Yes, that's right. But I found, like with lines, with contacts and things, that Strabo sort of has a depositional, and then there's a subfield for what type of depositional, and then for fault, there's a subtype for faults. On all of the databases I had previously, I had this, the subtype was all in one column, and now you need to put it into 3 or 4 different columns. So that's kind of the complicated part for sort of older data sets, for at least the way I had them formatted.
Okay, thanks very much.
For
These are
strikes and dips, I've found it to be a fair bit easier. Have you found that, Joe?
Yeah, for strikes and dips, it's much more straightforward, but the way that the subfields are for the contacts, I kind of wish there was a way to collapse all of that, but this is what we have at this point, so we'll go with it.
That's something we can keep working on. Okay, we got a minute or two before our next speaker, next presenter. Any more questions? I will just add that for part of the field work we did on the project that Joe just talked about, we put that up and made it, we're in the field in August and put it up and made it available immediately. We were able to get access to some of the parts of the military base that it cut through, and we're able to put up images and things that other people wouldn't necessarily be able to drive to or see. And we were able to put out a community plea to add data if anybody had any. That didn't go very far, but it was a good thought.
Doug, were you guys coordinating with Kate Scherer on that stuff? Were you part of that effort?
No, we were coordinating with the geothermal office at China Lake, but Kate, we shared all of our stuff with her. Basically, at this point, since all these projects are public, anybody could go in and grab the data and bring it in if they wanted it.
Doug, maybe we can kind of move into getting organized for the next presentation.
All right, so I'm going to stop my sharing. Our next presentation is going to be on Strabo tools. So the next 2 presentations are on developing new things with Strabo abilities, Strabo tool, and Strabo micro. One plug I'll put in, and I don't know if Alan Glazner, the next speaker, is going to say this, but one of the things that we need to keep thinking about is what can we do now that we couldn't do before, now that we have all the availability of mobile devices, taking them out in the field. So Rick will talk a little bit about that on Friday, and Alan will be presenting Strabo tools here. Alan, are you ready?
I am, now that I'm unmuted.
That's good.
Yeah. Am I up?
You're up, so go ahead, share your screen and get started.
All right. Well, I'm going to start out with something that I consider rather mundane, but Basil made me talk about it. So I'm going to talk a little bit about the igneous and metamorphic functionality within Strabo itself, and I'll make that fairly brief because it's fairly obvious. And then I will jump into talking about Strabo tools, which, as Doug said, I think is going to allow us to do things in the field that we just could not do before. A lot of what we're talking about now is making what we used to do with paper maps and so on easier. But I'm going to show you some things that will, we hope, kind of fundamentally change the way some people do field work. So you can see my screen here?
Yep.
Doug? Yeah.
Yes.
Okay. Okay, so this is a field trip we ran in Yosemite last GSA last fall, back in the days when we could all get together and go places. And we used Strabo as the guidebook in a way. And these are just some spots from a pre-run of that field trip. And I just want to show you very briefly some of the things that we've put in here for gathering igneous data. So here's a spot. I took some measurements on granodiorite in a road cut there by Olmsted Point. I've got an image or some images of the granodiorite and so forth. And if you're an igneous petrologist, something you might do here is want to write down the minerals and everything else. So we now have this IgMet heading up here with 3 tabs underneath it, rocks, minerals, and reactions. And you can go through here and I can say, well, that's an igneous rock, it's a plutonic rock, it's a granodiorite. Color index, percent mafic minerals. You'll notice it says select color index source. That's because that's the next thing I'm going to talk about. With Strabo tools, you can say it's a pluton, you can say something about grain size, and it goes on, and then you can add minerals. And I can say, okay, QZ, it figures out I mean quartz, and it goes on, and you can go as deep or as shallowly into this as you want. So this is just a way to put down the kind of information you'd be writing down in your notebook, but now it becomes digital and searchable and so forth. So that's all I'm going to say about that. What I'm going to do now is stop sharing this and share my main screen.
While Alan is making that transition, I'm just going to point out that 2 weeks from now, we're going to have another workshop that's going to focus specifically on metamorphic fabrics with a little bit of igneous. So if that's really your thing, you can just contact me. And several of us are leading that, including Mike Williams, Stacia Gordon, and Frank Spear.
So Doug, are you seeing the proper screen here?
Yep, and I'm going to try to put up my poll now.
So we're going to make this interactive. I'm going to just go through some of the common field questions we ask ourselves when we're in the field, things we write down, and just go through maybe 5 of these. And we have an anonymous poll here that we would like everyone to answer. And in the interest of moving things along, let's say we'll put the poll up for about 20 or 30 seconds. So the first one is, what is the color index of this granite? For those of you that aren't petrologists, CI is just the percent.
Hey, Alan, you've got presenter view on, so your slide 2 and 3 are showing.
Well, that's why I asked you. So
that
I
just
need to
came
cut
up.
that off. So let's see. I go here, do this. Actually, I think I just need to share the other screen. That was my mistake. Sorry about that.
No problem.
Share that screen. How's that?
There you go. Yes.
Okay. So color index percent dark minerals, it's a proxy for bulk composition. It actually correlates very well, and it would be nice if we could estimate it well in the field. So everybody just take a whack and answer this question. You've got, let's say, 15 seconds, and then we'll go to the next question. So we've just given you broad categories here. Doug, are the results roaring in?
They're roaring in. We have about 40 results.
Excellent. Don't say what they are.
51 results.
Excellent. Okay. All right, so I'm going to move on to the next one. So the next one, here's a deformed rock. It's obviously deformed. We can measure the strike and dip of the foliation of any fabric you see, and that's nice digital data that you can store and search on. But there's also this issue of the strength, and you might write down, well, this is a weak fabric or a strong fabric or whatever. So just very quickly, and we'll just say 15 seconds for this, just how would you characterize it out of these 3, weak, moderate, or strong?
We're up to 50 people now have responded, 55.
Okay, so the next one, here's a granodiorite. And when you're working in granites like this, you're always looking for some kind of a fabric. So the question is, does this rock have a fabric? Do you see a fabric? And if so, which way is it oriented? Maybe there isn't one. We've given you every 30 degrees if you see a fabric for you to write that down. So up or north is 0. It's usual azimuth clockwise from north or up. Doesn't look very deformed to me. Not that I'm trying to bias anybody. Okay.
We're now to 55. Over
Okay.
75% have responded, so we'll end this poll.
So we'll go to the next one. So here is a vertical cut in an alluvial fan, a shadowed face. And the question is simply, is there an imbrication? Is there an orientation to the long axes of the cobbles and pebbles?
And we're up to 25.
This is great. Is anybody getting them right?
Well, I don't know what's right. So we've hit 55, 75% of the people have voted.
Okay, let's go to the next one.
Okay, ending this poll.
The final one, these are two random pebble patterns that I made. And one of them is a deformed version of the other. So I just told you one of them's deformed, so you can ignore the first answer. But do you see a fabric in either of them?
This one's coming in a little slower.
Yeah, okay. All right, well, we will leave it at that, and I'm gonna go back to the iPad and show you how to use Strabo tools to answer these questions. So Strabo tools is a kind of an offshoot of Strabo. It's not funded by Strabo, except that Jason Ash is the critical link in that he is the one who turns the MATLAB that I write into something usable on an iOS device. So I think that I have these images here. There's the first one. So the first question,
You're not
can you see
sharing
this?
yet.
Is this coming through, Doug?
Nope, you're not sharing yet.
It's because you have to hit that second share. There we go. Oh, and I got to do this. And there we go. Got it?
There it is.
So I'm going to cheat a little bit. I'm going to bring this up in edge detect mode and turn that off. So here is that first image we saw. And the color index, again, is a fairly well-defined, simple thing, but it is kind of hard to estimate. Doug, can you look at the answers to that first poll?
Yes, I can.
So
And
what
I'll
did you
share
get?
them.
Okay. Well, you'll have to read them off. Oh, no, you put them up there.
Yeah.
13, 38, 22, 25, 2. Okay, so if you have Strabo tools enabled on a mobile device and you're looking at this presentation on something else, you can follow along and determine the color index yourself. So what I'm going to do here, I have the image. I'm going to show you how to do it. So I'm in Strabo tools. I've loaded this image. I hit color index and I get this view in a slider. Goes from 0 to 100%. And what I want to do is just move the slider until I cover up all of the black stuff, but I'm not covering the smoky quartz and other things that I don't want. I kind of like that, and then I can hit the on off button and look around and make sure that's representative, and I got 11%. And that's actually the most common answer in the poll, so congratulations. But you'll see that the numbers range from 5 to, well, all the way up to 30, but you know, most of them, there's quite a wide range, including a lot of estimates that are double what the actual number is. And that's quite common even among pros in estimating color index. So this is a fairly reproducible and easy way to get this important number. A lot of plutons are zoned in color index, and there's no way you could make these determinations by eye alone unless you're really special. So we think this is going to offer a way to do quick and dirty zone mapping in plutons.
Not so dirty.
Not so dirty. Okay, let's look at the second one. The second one was this one. And I will again pull it up. It comes up in the last mode you used, which was color index, which isn't so useful. If I go into edge detect and turn it off, there is this deformed, this is the margin of a pluton where it had it has an annealed myelinitic fabric. And what was the most common adjective there? Strong, okay.
Yep. Almost everyone said strong.
Yep.
30% said weak to moderate.
Yep, it would be nice to be able to put a number on that, and using a tool that, I'm not going to go into detail about how it works here because I don't have time, but the edge fabric.
I'm still seeing this saying setting up color mode.
Say again?
It's still stuck on setting up color mode on my screen. Maybe mine's just frozen.
Nope, mine too.
You're seeing
the word setting up color mode.
Huh, because it's come, I mean, it's on my screen. Is anything changing?
No.
Bummer.
Maybe you have to unshare and reshare.
All right, stop share, share, reshare, share. Now I got a screen mirror. How about that?
There you go.
Okay, so this is a measure of the fabric in the rock, a quantitative measure of the fabric in the rock. In the upper right is the azimuth of the long axis. The red is the blue is a reference circle, and the red is an ellipse derived from this image. The azimuth is the angle it makes with north, clockwise, normal geologic convention, and the axial ratio is just what it says, the long axis divided by the short axis. You'll see the camera icon. You can save a screenshot of this. Under that is trend and plunge, which is blank, but I'll show an example of where that isn't blank in the future. And finally, the 9 numbers underneath the words trend and plunge are the orientation matrix of the iPad itself. And that gives the orientation in space of the iPad, and we use that to derive the orientation in space of the long axis of this ellipse. And I'll go into a little more detail on that in a minute. So let's look at the next example. Which one was that? That was this guy. Is this rock deformed? Oh, this is a good crowd. I deformed this one by squeezing it 5% along an azimuth of 0.30. That's the fabric that most of the people saw. That's really good. It's subtle. I think it's subtle. And you'll notice that the edge fabric ellipse, the red one, has an azimuth of 0.30.6. So that's pretty darn close. The axial ratio 1.1 is about what you would expect for 5% pure shear shortening and elongation in the other direction. So this method is pretty good at picking up things that are quite subtle. I don't think I would call this something I would measure in the field and map, but maybe many of you would, because you seem to be, this crowd seemed pretty good at picking this up unless you cheated and already knew the answer. So I'm impressed by that. The next one was the, not favorites, recents. The pebble imbrication.
Yep.
And so people had it just about right. So the bedding in this, I held the camera horizontally and the bedding is just about right. But when you do an edge fabric on these, I did about a dozen photos along this face, about a 100-meter stretch. And they consistently gave me edge fabric ellipses that were rotated 20 or 30 degrees counterclockwise from the bedding. And I interpret that as the dominant long axis of the pebbles and cobbles, and that's actually what I see. So I think in this case, it's picking up an indication of the imbrication. When I've tried this, it's worked pretty well, but it would be nice for some people who actually deal with these kinds of rocks and know what they're seeing to work with it better. Stream flow in this image was, this is a vertical face in an alluvial fan, and the intermittent water flows left to right. So that's consistent with this. So that's a subtle fabric that it picked up. And then finally, are we to the last one now, Doug?
Yes, we are.
Okay, so here is the left of the, and what are the answers? Left, north-south elongation. Okay, so here is the left photo. And there's no fabric. You know, the elongation 1.03, that's basically random, the axial ratio, okay? The right photo, I squeezed it 10%, I think, yeah, 10% east-west. I can't see it, Doug can't see it. A third of the group saw it, but it's pretty subtle. So this edge fabric ellipse is pretty good at picking those things up. So.
And it checked out pretty well with the deformation you actually imposed in it.
Yeah. Wow, where did those lines come from? Are you seeing lines on this?
Yeah, that's nice.
That's very strange.
Alan, there's some questions about how the edge detection is working. Could you just, since it's up on your screen, just show us a little bit about that, or just explain it?
Let me pull. This is so weird. They're, oh, now they're gone. Okay.
Yep.
Now they're back.
If any of the participants can grab annotate, if you go up to the top.
Oh.
Right. And so that's what I just did too, to see if that was working. So I did the red line.
Okay.
But I've had, like, you can do that in class, is show a photo, and then if students are on a Zoom session, synchronous, you can have them use that annotate tool. So someone else was doing the blue lines.
Okay. All right. So a quick introduction. Can you see this other screen now?
Yes.
Okay. So quick introduction. This is, you know, I came up with a color index tool, and that was very obvious and easy. And then I was thinking, what can you do about preferred orientation? And after a lot of reading and a lot of playing around with various things, I came up with this, and it seems to work pretty well. So here is a grayscale image of two gray lines and a dot. At each pixel, so this is a 50 by 50 image, just for simplicity. At each pixel, there is a vector that defines the brightness gradient. So a vector that points in the direction of increasing brightness, and its length is proportional to how sharp that gradient is. So along the edges of these things, well, let's look at the dot. Along the edges of the dot, there are long vectors pointing away, perpendicular to those edges. And you see my cursor?
Yes, we can.
Okay.
Yes.
And then along the lines, you see, again, perpendicular vectors perpendicular to the lines pointing away. So there are a lot on the sides pointing in opposite directions and a much smaller number on the ends. And so in C, I've taken all of these vectors, translated them to the origin and changed the scale. And then we take the variance covariance matrix of those. So this is just basic Bingham statistics. And so these two black arrows are the long eigenvector and the short eigenvector of the variance covariance matrix. And because because this is giving us the short direction and we want the long direction, we just simply, they define an ellipse and we just rotate that ellipse 90 degrees to get the edge fabric ellipse. That's all there is to it. It's actually quite simple. So,
out in GSA today, next month.
Yeah, I'll get to that. So in the field, in the field, this is basically how it works. You take the device, an iPad works better for a lot of this, especially color index. You hold it parallel to the rock surface, take the picture, and there are a lot of caveats about that that I won't go into right now. And so you get the azimuth. The azimuth is the orientation on the surface of the device. We used to call it the eigenvalue ratio. Now it's the axial ratio. It's the same thing. We just changed the name. And the trend and plunge are the trend and plunge of this axis in space. That's not relative to the iPad. That's in space. So that's a part of the strain ellipsoid. So just to give you, this is an early example that Doug did. Doug was in the field in January in the Cronies Hills, Mojave Desert, and he had these really strongly foliated metavolcanic rocks. And with an early version of Strabo tools, he went around to 8 spots and did edge fabric ellipses. And then he transferred those to StereoNet, Allmendinger's StereoNet program, and plotted them. There are these blue lines, and he fit a great circle, which is the black line. And then he set his iPad down on the top of the outcrop, which happened to be a bedding plane. And he looked at it and he said, what's that red line? And that red great circle is the live measurement from StereoNet of the bedding on that surface. So he took these 8 measurements from various places on the sides, derived the bedding from it, and got an amazingly good match. And he said if he hadn't done that, he never would have believed that that actually worked out that well. Now you might say, why would you even bother? You've got the bedding surface, but you can imagine in a place where you don't have this kind of exposure, you might get a little bit of an outcrop here, a little bit of an outcrop a quarter mile away there, and so on. That might be defining a nice fabric that you just can't see because you're just feeling little pieces of it here and there. So we're hopeful that by putting together edge fabric ellipse data from a lot of places, you can derive fabrics that you didn't know were there. I'm really looking forward to getting out to Yosemite and trying this on the very subtle fabric in the granodiorites out there.
We've got about 5 more minutes, Alan. The other thing I would add is I did that on a bunch of granites and over kilometer scales, they gave relatively consistent results.
Okay, well, I've got some important things I want to get to, so I'll pick it up here. So I'm not in presentation mode now, but this is a classic. I'm not sure which screen you're seeing, probably the wrong one.
Figures now.
Yeah, that's okay. So this is a classic Ramsey and Huber deformed quartzite. This is a Fry analysis that's in their book. 5 seconds, the edge fabric ellipse matches their Fry analysis, which they admit is pretty inconclusive, pretty well. So it's a great time saver. Here's an artificially deformed quartzite. The imposed deformations in blue, the edge fabric ellipses in red. here are random sized, random axial ratio, randomly rotated ellipses that I applied a deformation to. How would you analyze this by standard techniques? Probably with RF phi analysis. Here's the RF on the right is the RF phi scatter of points. How you would pull an answer out of that, I don't know. The imposed deformation is in blue. The deformation derived from the edge fabric ellipse is in red. So again, this is a 5-second analysis as opposed to whatever you do for RF phi. We're kind of excited because this is going to give you the opportunity on an outcrop like this to put quantitative numbers on fabrics that you see. So you can kind of map out strain gradients in the field. You don't have to take oriented samples and do all the work you have to do, cutting thin sections and so on to do this. So we are quite excited about that. I'll skip that. Okay, I'm gonna bust out of this and go to MATLAB real quickly. So one thing, Doug and I have been spending way more time than we should working on this kind of thing. But you see this ellipsoid here. This is an ellipsoid with a long axis of 2, intermediate axis of 1, and a short axis of 0.5. And I'm going to subject it to 500 random cuts through the center, which is the equivalent of 500 outcrops with differently oriented faces, and plot up the long axis of the edge fabric ellipse, which is in red, and the short axis of the edge fabric ellipses are in blue. And you can see that the long axes define a very nice plane, the AB plane of the strain ellipsoid. And you can very easily, again with eigenvector analysis, derive the long and short axes, well, the orientations of the 3 axes of the strain ellipsoid if you have sufficient measurements. And then I'm very happy to say that Doug and I have worked out how to take the edge fabric ellipse data and solve for the 3 lengths of the strain ellipsoid. So again, that's a work in progress, but it's moving right along. So we're very excited about that. Doug, do I have a few minutes just to show modal?
Take a minute or two on modal. We got to finish up pretty quick.
Okay, so one more thing. Going to go back to the iPad and share it one more time. And then I'll shut up. Share.
It's showing the iPad.
Okay, Strabo tools. So if you're a petrologist, I keep hitting favorites. One of the things you do really often, or you're at least supposed to do, is you're supposed to look at a rock like this and estimate the proportions of the minerals. Modal analysis. So color index is part of that. But to classify this, you want to have the proportion plage, proportion quartz, proportion K feldspar. And I am working on a modal analysis tool that is still in beta, but it's coming along pretty well. And so this is an unsupervised classification of that image. And the key, I'll just tell you what they are. You just match the key to the image without the colors on it. So black, 9.4, that is mafic minerals. The white, 37% is plage. Pink is K feldspar. Green is quartz. And this is the half dome granite diorite, and that is pretty much bang on a normal analysis, modal analysis of the half dome granite diorite. And one thing, so that's kind of surprising that it's so good. Another thing is that when you take the complicated nature of a real rock with all its fractures and everything like that and simplify it into a map like this, a color map, you see relationships you didn't see before. And one thing that jumps out at everybody here is the mafic minerals tend to be surrounded by quartz. Mafic minerals are very strongly associated with the quartz, the green and the black here, something that I have never seen mentioned in a book. I had never noticed it myself. It doesn't jump out at you when you're just looking at the rock. So we're hopeful that these tools will be very useful in the field for seeing things we just couldn't see before and measuring things that we just couldn't measure before. So I will stop there. Thanks.
All right. Go ahead and if you can, if you have questions for Alan, go ahead and put those into the chat. Alan, you can respond to chat, and then also you can put them up on the Google Doc. Let's just keep forging ahead with the last presentation for today. Hopefully doing more things that you couldn't do otherwise, and that's Strabo Micro.
So as I understand it, Noah, you're going to take this away.
He started screen sharing. Hopefully he's unmuted.
Okay, I am now. So, hopefully let's go to the slideshow mode. All right, so my name's Noah Phillips. I'm a postdoc with Julie Newman at Texas A&M, and today I'm just gonna show you Strabo Micro, what it is, where it's, and where we're going with it. Obviously, I'm part of a group that's working on this. Julie Newman's really the head PI. Jason Ash has been doing all of the hard work programming this up. And Nick Roberts and Randy Williams have been sketching up mock-ups for the programming. So Strabo Micro is just our thin section scale observations. And the reason that we want to have a separate app within the Strabo system for this is so that we can quickly locate our thin section observations to the field location where they came from, or from the experiment that they came from. And our goals with Strabo Micro is to seamlessly integrate observations across many scales and make our data fair, so findable, accessible, and reusable and interoperable. The final thing we really want it to be great at is being a digital notebook, so that when we're making microstructural observations, that they're getting permanently recorded and that other people can access them and find them really easily. So we want it to be a permanent, shareable, legible notebook. I know my notebooks frequently aren't that legible. We want to be able to tie thin sections to precise field locations or the corresponding experimental results they came from. And then within individual thin sections, we really want to be able to correlate things across scales. So we want to know where, say, photomicrographs taken on a TEM at the nanometer scale, where they are on the thin section scale, and then where they came from in the field. And then we want to be able to take a bunch of different data sets and be able to relate them to one another. And so that'll be chemical data, orientation data of the grains, age dating, mineralogy, reactions, grain sizes, you name it, we want it all in one place so that we can quickly relate these things to one another. And then finally, and perhaps most importantly, like with the other apps in Strabo, we want to be able to search the database and be able to search for the data that we have. And so this is where the vocabulary, different people have talked about this for Strabo Sed and for Strabo Spot in general, where the vocabulary becomes really important. And there's been a series of workshops to develop the vocabulary for Strabo Micro. Okay, so I'm going to just open up Strabo Micro now and show you where we're at by starting a new project. So hopefully you guys can all see the Strabo Micro app. This is a desktop app. It's currently not available because we're currently making it, but we're hoping to have it up later on this year. So what I'm going to do is I'm going to start a new project and show you kind of how this works. I'm just going to call this project Strabo Structural, and we'll make it a default data set. And I'm going to upload some images from a thin section I have from the Sulu ultra high temperature terrain in China. And I'm going to show you a Sulu garnetite. So when we're filling these out for permanent storage on the Strabo system, obviously there's a lot more things that we want to record, and we have drop-down menus and open text boxes to help you move through describing your samples. All right, so the first thing we're going to do is load a reference micrograph. In most cases, this will be a thin section scan. And what I'm going to upload now is a plain polarized light photo mosaic that we'll use to co-locate all our other images. And there's a couple ways to set the scale on our reference photomicrograph. In this case, I'm going to trace a scale bar. So we'll take a minute to load the image because it's a rather large image. And here we go. So here's our thin section scan of our garnetite. So all the pink is garnet, and all this light bluish color here is amphicite. And so I can take a line, put it across my thin section, and since it's a standard thin section, I know that that is 27 millimeters across. And that's gonna set the scale for my photomicrograph. And that's gonna save it and bring it into the system. All right, so now I have my photo mosaic of my thin section, and I want to bring in thin section. So I'm going to add an associated micrograph. And in this case, I'm going to pull out an EBSD phase map. So a map that was collected on the SEM using an EBSD detector. And it's going to show me the distribution of my phases and the grain boundaries associated with them. And then when
for me, I get the sense you're on my screen. Your screen is lagging by about 20 seconds or so from what you're saying. I'm not sure if anybody else is experiencing that, but just heads up.
Okay, I'll slow down then.
I'm seeing okay.
Okay, might be just me. Go ahead.
Okay. So I'm going to load in this EBSD phase map, and I'm going to locate it onto my reference micrograph using a scaled rectangle. And then it asks me how I want to set the scale. So I know on this micrograph that I'm going to be importing in that I don't have a scale bar. And so what I'm going to do is I'm going to stretch and drag my image to locate it onto my reference micrograph. So I click next. And this brings up a set micrograph location and scale window. And what I can do is I can take this phase map and place it where I know it is located on my reference micrograph. So I know that these amphicite grains here in the phase map correspond to these ones on my reference micrograph. And so I'm going to rotate it a little bit and resize it so that it lines up with those appropriately. And I can zoom in and out and move things around as I do this. The other really nice feature when you're working on this is that you can change the opacity so that you can make it more or less opaque to really get your bearings and get everything lined up properly. All right. So once you have that decently co-located, I'm not going to get it perfect here, but we should get it pretty close. You can click, and that's going to basically permanently reference this micrograph onto your reference photomicrograph. And you can have different layers of features on here. So I can add an associated micrograph to my associated micrograph. So I'm going to add a calcium map that was made on the probe. And again, I'll locate it as a scaled rectangle within my previously existing micrograph. So in this case, I know that this garnet grain here corresponds to this garnet grain. So I'll just try to resize it so that those overlap with each other nicely. All right. You can click finish. So that's where we're at right now for a kind of basic usability in terms of uploading photos into the system. And now we can easily see where our WDS map is relative to our phase map. And then once again, where our phase map is relative to our reference micrograph. So once you have a bunch of photos loaded up, you might want to start describing your thin sections. So there's going to be this big note pane here on the bottom where you can kind of free type notes. And we're going to have tabs on this side where we can set, describe different aspects of the thin section. So here we have a mineralogy box. So we can click on set the mineralogy. And for this thin section, we can see that it's mainly garnet, in this case, almandine. So I'm going to start typing almandine, and it automatically populates with all the possible minerals that it could be, with the most common ones at the top. So I'm going to add almandine, and I'm going to say that I know that this thin section is about 80% almandine. I can start adding other mineral names. So we know that this light blue mineral here is amphicite. So I can add that in relatively quickly. And I can add in things like, I know that there is rutile and there's late clinozoisite in the fractures. If I know that there's trace of something, I can always add in, so say there's trace pyrite along some of these late fractures, I can say that there's less than or greater than a certain percentage of something. And then you set how the percentages were calculated and how the mineralogy was determined. And that's still a work in progress. All right, so now you can see that we populated this data. So it's now permanently stored with this thin section. Like in other aspects of Strabo Spot, we can create different types of spots. So if I want to locate features with a point or a line or a polygon, I can do that. And so these are all coded up now so that you can create spots just by clicking your way around different features that you're interested in. And then you can describe the spot and name the spot. All right, I'm going to pull up another project where I have more things loaded in. That.
Noah, in the interest of time, this has been great, but I think maybe let's stop it here. Let's see if anybody has questions in case people need to go. And then if people are interested, we can just do this afterward. Does that seem reasonable?
Definitely.
So yeah, I just want to make sure that just in case people want to go, that we have time to do that. I guess I should announce that tomorrow we're going to do some teaching activity things. So Casey Duncan and myself both did teaching activities, and we'll show those for a little bit tomorrow. That should be no more than about 40 minutes, and then we will take questions otherwise. And so if anybody has issues about their projects or just clarifications, we can do that. So I think some of the questions that came up is, can the thin sections be used with Strabo tools? I think the answer is yes. Right now you'd have to sort of toggle between the two approaches, but the idea is that that will all be wrapped up. Doug, do you want to say anything more about that?
Yeah, because we're going from MATLAB into this, Jason has been working on what that connection is. And the idea would be that you would be able to use Strabo Micro and just bolt in whatever tools you commonly use. We're planning towards that connection, but it hasn't been built yet.
Right. So like Doug said, eventually all of the tools available in Strabo tools will be available directly within Strabo Micro. So you won't have to do any kludgy transfer of files or anything. It'll just be.
And if you're building your tools, if users are building tools in MATLAB, they should be able to bring them in themselves.
Right.
Jason, while you're still online here, is there anything you'd like to add to Noah's very nice demonstration for the micro tool?
No, just that the small bit that Noah talked about on the side, adding spots and adding metadata to the micrographs. That's kind of the portion I'm working on right now. So that will be greatly expanded very soon. So
Can I just add something about how it's set up? So one thing that Noah didn't show is that you can sign in to your Strabo Spot account and pull down or directly reference samples that you collected in the field. So you can pull down samples from a project and then add photomicrographs to those samples.
Right, Nick, that's a really important point. So this is where the sort of the Strabo tools and the Strabo Micro is where we're going beyond anything GIS could possibly do, because we're going to sort of the use of different tools. And the other tool that we will be developing in the next few years are statistical tools that you can use for a variety of field measurement techniques. So that's the huge advantage of sharing the data. And moreover, so when Alan does things for petrology, the structural geologist can use it, the sedimentologist can use it, the petrologist can use it, and vice versa. If the petrologist develop things, then all the other communities can use it. Doug, is there anything else you want to say, except then on Friday is when we will actually have the presentations for the people, and Randy Williams will be coordinating that, and he's been in touch with you.
That is correct. And we'll have a little bit more interoperability from Rick Almendinger on Strabo and StereoNet, Faultkin, and GMDE. And I think that's probably it for today. And does anybody else have anything else they want to add or ask? All right. Should we go ahead and end it for today then, Basil?
I think so. I think if people are interested in sticking around to have Noah demonstrate the last part of that, the last part of his demo, that would be fine. I'm sure he'd be happy to do that. But otherwise, we will see you all either on Thursday tomorrow at this time at 1 o'clock, or on Friday for sort of the wrap up.
And I'll leave the recording on for Noah.
All right, great. I'll just show a couple other small things really quickly.
That'd be super. And again, remember that you can, and anybody can use the Google accounts to ask questions at any time.
Yeah, and at this point, feel free to interrupt if you have a specific question by unmuting yourself. So one of the nice features that's been mocked up here is that we have this groups tab. So in the samples tab, you can have multiple samples from various locations. But in the groups tab, you can start to organize things by specific features that you want to see, or by specific features, or by specific data types. So let's say I want to have a group that shows all of my WDS maps showing calcium zonation. What I can do is create a group that says that, and then I can simply select from all of my micrographs data sets that have calcium WDS maps and turn that into a group so that I can quickly compare them with one another. That's all I had from this interface. In terms of where we're going moving forward, there's going to be tools at the top for making measurements or looping different spots that you've created. We've got a ruler that's going to show the scale and have a common reference coordinate system across scales, which is always going to be 0, 0 in the top left, and then increasing as you go to the right or down. And this has been outlined in detail in a paper by Basil and Nick. And we're also going to have these kind of speed spots. So these are geo emojis that show a specific feature. In this case, it's a left lateral sigma class. So what you would do is you'd click on the geo emoji and then click everywhere on your thin section where you see a left lateral sigma class, and that'll create spots with location and data already input saying that there's a left lateral sigma class there. And then finally, I showed you the tab for mineralogy, but there's going to be other tabs for fabrics, grain shapes, and orientations, as Jason mentioned earlier. And yeah, that's all I have.
Great, thank you, Noah, and sorry to cut you off, but I felt like we needed to sort of respect the time we told people that we would take.
Yeah, that's fine. No problem.
Okay, we will stick around. The organizer will stick around for another 10, 15 minutes or so. If anybody wants to ask questions, otherwise we'll see you Thursday or Friday. So thanks again.
Sorry, Basil, I had to step out for a second. Is that it?
That's it. It's all good. We're just gonna see if anybody has questions. So Carlos, so I think you can stop the recording, Doug, at this point.
Okay.